Okay, problem number one. The break-even markup was 40% of the selling price. So I see the word markup. I initially think we got purchase price, we got selling price, we got markup. Usually use that for markup. So M goes there, equals, equals, equals. I don't want to do anything about M until I know what purchase price and selling price are. So if I keep reading the problem, the hardest part about this problem, I think, might be some of the wording, the way they word things, maybe not understanding what things are. So we think about the total income for a day, which the store broke even, was $9,600. So the total income was $9,600. Income is what the store took in from the consumer. So they're selling items, and altogether the items they sold equaled $9,600. That's the selling price in this case. How much did the store owner pay for the items sold? So we don't know that. We'll call that X. And once we know both purchase price and selling price, either as a variable or a number, now we're ready to find markup. Markup is 40% of the selling price. So 40% of 9,600. Since they're both numerical, I can actually get a number answer for that. So 0.40 times 9,600 is a markup of $3,840. And what we know about this problem, this type of problem, is that the selling price is equal to the purchase price plus the markup. Whatever the store owner paid for the items, plus however much he marks the price up, equals how much he sold everything for. Move the 3840 to the other side, and it's a simple algebra equation. $5,760 is the purchase price of all the items sold. Number two, Cindy noted the sum of the digits of a two-digit counting number was 12. As soon as we see two-digit counting number, we want to construct a structure of that, which is a tens number, a tens digit followed by a units digit. Tens and the t's in the tens place, u's in the units place. So the sum of the digits is 12, so t plus u equals 12. Second statement, the digits were reversed. The new number, okay, so the new number is the reverse number. So the reverse number looks like this. So if I'm looking at the number itself, that's 10u plus t. Was means equals. 18 less than, we couldn't care less about yet. And then the original number is this number, which is 10t plus u. And now the 18 less than matters. This is 18 less than this, so minus 18. I don't know why 10t plus u, not 4. Kind of looks like a 4 there, so 10t plus u. So the reverse number 10u plus t equals the original number minus 18. Now if I just simplify this, I'm going to move the 10t over here, move the u over here. That gets me 9u minus 9t is equal to minus 18. Which means that u minus t is equal to negative 2. So if I take that equation, put it over here, and I line things up. So t is here, that has a negative t. U is here, so plus u equals negative 2. This equation here matches that, just I swapped the order so things lined up. T and negative t cancel, u plus u is 2u, 12 minus 2 is 10. Divide by 2, you get u equals 5. The sum of the digits is 12. 5 plus 7 equals 12, so t is equal to 7. What was the original number? This is the original number structure. T first, u second, 75. Number 3. Yellows vary directly as green squared and inversely as blues. So yellows vary directly as green squared, inversely as blues. So if I do the equal ratio technique, yellows varied directly and inversely. So we'll start off with the yellows. I'll use red for yellow. So yellows, that's y sub 1 over y sub 2. Greens squared, that's g squared over g squared. And it says directly, which means subscript 1 on top, subscript 1 on top, 2 on bottom, 2 on bottom. These are subscripts, these are powers. So greens are being squared. First green, second green, squared, squared. Inversely is blues, that means blue on top, blue on bottom. Inversely means to invert the subscripts, so 1 on top, 1 on bottom, 2 on bottom, 2 on top. And then once we get everything set up properly, now we simply need to substitute the numbers in where they belong to get the setup here. So, when there were 80 yellows, that's the first yellow, 80. There were 15 blues, that's the first blue. And only 10 greens, that's the first green. And notice, it says 10 greens, but this is greens squared, so 10 squared is 100. So as I enter the greens, I simply square the number. Then it says how many blues went, so we don't know B sub 2, the final number of blues, 120 yellows, and 10 greens. Again, that's 10 squared, so it's 100. So at this point, I could cross multiply immediately if I want to. I could reduce fractions too. Let's do that. That reduces that out completely. Let's just go and let's maybe divide by, let's go 10. So that's 8 over 12 at least. Make the numbers a little bit smaller. If you want to make it even maybe 2 over 3 by both by 4, that's even easier. So that gets me 3b sub 2 is equal to 2 times 15. So b sub 2 is equal to 10 blues. Be careful you square the greens because it says green squared. So if it said greens, then it's greens, green squared, green squared. So make sure you do that properly. Number 4, the current in the river was 4 miles per hour. It's the boat in the river problem. What was the speed of the boat in still water? So that's my first priority. Speed of the boat in still water, I don't know. The speed of the current is 4. And my categories are always downstream and upstream in these problems. The rate downstream is the boat speed plus the current. Upstream is the boat speed minus the current. In each case, I don't know the boat speed, but I do know the current speed. So I can put b plus 4, b minus 4 for the rates. It says in the same time, which means I don't know the times, but they're equal. And we're going 100 miles downstream and only 60 miles upstream. So that's priority 1, to create the chart after you've established what the boat and the current can go. Then it's rate times time equals distance. So binomial times one thing, so distributed property bt plus 4t is equal to 100. Distributed property here also, bt minus 4t is equal to 60. If I add them together immediately, the 4t's will cancel, but I'd rather get rid of the bt's. So I'm going to change the signs. This becomes negative bt, positive 4t, negative 60. bt minus bt cancels. 4t plus 4t is 8t. 100 minus 60 is 40. T equals 5 hours. How long did each trip take? Same time, 5 hours, so that's one of the answers. The other thing says, what was the speed of the boat in still water? We're trying to find out what b equals. I know that bt plus 4t is equal to 100, but t just equals 5. So this is 5b plus 4 times 5, 20 is equal to 100. Minus 20 goes here, so 5b is equal to 80. Divide by 5, we get b is equal to 16 miles per hour. So you will be asked for both numbers on the test, so make sure you find both things. Usually you find time first and then use time to find the other thing you're looking for. Number 5, we have a difference of cubes. Divides by 3, divides by 3, divides by 3, and 27 is 3 cubed. So we have perfect cubes being subtracted, so the factored form is first parentheses, cube root of both objects with the same sign. So divide the powers by 3 to take cube roots of letters. So x to the first power, y to the second power, z to the first power. Take the cube root of the number, the cube root of 27 is 3. 3 times 3 is 9 times 3 is 27, so 3 is the cube root of 27. So numerical cube roots, letter cube roots divide by 3. 3 divided by 3 is 1, 6 divided by 3 is 2, 3 divided by 3 is 1. The second parenthesis has 3 exact objects. It has something plus something plus something. It's plus because that's minus. This sign's always opposite that sign's always the same as that sign. So minus, minus, change the sign, this one's always plus. If this said plus, this would be plus, this would be minus, this would still be plus. First object is whatever this is squared. xy squared, double the powers. X to the second power, y to the fourth power. This is just these two things multiplied together, ignoring signs because we already know it's supposed to be positive. 3 goes in front, x, y squared, z. Always put numbers in front. If there was a number here, let's say this said 5 and this said 3, this is going to be 15, not 3 times 5. So make sure you multiply things together you can. And then finally, this thing squared, 3 times 3 is 9, z, you double the power. And that's it. So that is our factored form for that problem. Number 6. We had this come up in homework too, and some of you didn't know exactly how to handle it. Basically, if you just evaluate this, 25 minus 16 makes square root of 9, which makes 3. So this side is just 3, that equals the nth root of 81. And what they're asking for is 3 raised to what power equals 81? So if I try it out, 3 times 3 is 9, times 3 is 27, times 3 is 81. So 3 times 3 times 3 times 3, that's a total of 4 3s. So n has to equal 4. Because the fourth root of 81 is 3. If it was 27, n would equal 3. If it was 9, n would equal 2. If it was 243, which is 81 times 3 is 243, it'd be 5. So however many times you have to multiply this number to get that number is what you're looking for. Number 7, graph. We have a parabola. So what I want to look at here, first of all, is the vertex value I'm going to use. It's always the opposite of b. b is positive 2, opposite's negative 2 over 2a. a is positive 1, 2 times 1 makes negative 1. That gets me a chart here. And I want negative 1 in the middle. Two numbers smaller than negative 1 would be negative 2 and negative 3. Two numbers bigger would be 0 and 1. And then all I'm doing to evaluate y is I want to do x squared, I want to do 2x, and I want to do minus 3. X squared just means to square x. Squaring x makes a positive every time. So negative 3 squared is positive 9. Negative 2 squared is positive 4. Negative 1 squared is positive 1. 0 squared is 0. 1 squared is 1. 2x means to double x. Keep the sign what it should be. So 2 times negative 3 is minus 6. 2 times negative 2 is minus 4. 2 times negative 1 is negative 2. 2 times 0 is going to be plus 0. 2 times 1 is going to be plus 2. And then minus 3 just means minus 3. And then we just evaluate each one to get the y value. So 9 minus 6 is 3, minus 3 is 0. 4 minus 4 is 0, minus 3 is negative 3. 1 minus 2 is negative 1, minus 3 is negative 4. 0 plus 0 is 0, minus 3 is negative 3. 1 plus 2 is 3, minus 3 is 0. So this x paired with that y makes my ordered pairs. Negative 3, 0. Negative 2, negative 3. Negative 1, negative 4. 0, negative 3, and 1, 0. Connect the dots with a nice smooth parabolic curve. And the final thing we want to draw an axis of symmetry in. Axis of symmetry goes through the vertex. The vertex is occurring at negative 1. So the vertex is right here. Draw a vertical line dashed through negative 1. And we put a axis of symmetry x equals negative 1. Put that on the graph itself. Make sure that's very visible. Identify AOS. X equals numbers, not AOS equals negative 1. X equals negative 1 is the equation of that line. Number 8, we have a fraction equation and a decimal equation in a system of equations. First thing I want to do is get rid of the fractions, multiply by 20. 20 divided by 5 is 4, times 2x is 8x. 20 divided by 4 is 5, times negative 1y is negative 5y. 20 times 4 is 80. The decimal equation, I want all the decimals to disappear. So 3, 1, 2, so we need 0.0200y, and this is going to equal negative 1.720, and that's negative 0.008x. Everything has 3 decimal places now. Drop the decimals off. This is negative 8x. That's going to be minus 200y. That's going to equal negative 1,720. So now, I've got a system of equations, no fractions or decimals, and it just so happens in this specific problem, 8x minus 8x is going to cancel, so we're ready to go immediately. So if I add the equations together, 8x minus 8x cancels, negative 5, negative 200 make negative 205y. 80 minus 1720 is negative 1640. Divide both sides by negative 205. gets me, I believe, 8, just be safe. 1640 divided by 205 equals 8. Once I know what y equals, I go back to one of the equations. I like the blue one better, the numbers are smaller. 8x I don't know yet, minus 5y. Y is 8, and 5 times 8 is 40, equals 80. So 8x equals 120 if I move the 40 to the other side. And that means x equals 15. Once I know both x and y, my final answer should be written as an ordered pair, 15, 8. I am looking for an ordered pair answer. If you give me x equals y equals, I'm going to start counting off half because you guys have been in this class long enough that you should know better. So ordered pairs for answers on those. Number 9, solve. We have a nonlinear system of equations here. The variable types don't match, x squared, y to the first, x to the first. So substitution must be used. I move the 2x to the other side. Y equals 2x minus 4. So this y is going to change to 2x minus 4, so it's going to create x squared plus 2x minus 4. The quantity squared is equal to 13. So x squared plus, now squaring a binomial, square the first value, that's 4x squared. Double the product, 2 times 2x is 4x times negative 4 is negative 16x. And negative 4 times negative 4 is positive 16. And now that it's a quadratic equation, I want it equals 0, so I'm going to move the 13 over here, combine like terms. X squared plus 4x squared is 5x squared, minus 16x plus 3 is equal to 0. Okay, I'd probably apply the quadratic formula at this point. Notice x is the variable we're working with, so x equals, don't forget the x equals. I create the structure for the quadratic formula and I start working it out. The opposite of b is going to be positive 16. 2 times a is going to be 10. B squared minus 4ac. 256 is 16 squared. Negative doesn't matter. If you square things, you get positive. Minus 4 times 5 times 3. That's 256 minus 60, which is 196. Just so happens 196 is a perfect square. So x equals 16 plus or minus 14 over 10. 16 plus 14 is 30. 16 minus 14 is 2. So x is going to equal 3 and 1/5. Now we have to find y. Use this equation to find y. So for x equals 3, y is going to equal 2 times 3 minus 4. 6 minus 4 is 2. For x equals 1/5, y is going to equal 2 times 1/5. Minus 4. That's just 2/5. 4 is the same as 20/5. Y is going to equal negative 18/5. This x goes with that y, this x goes with that y. And once again, ordered pairs are the answer. So, x3, y2, and x 1/5, y negative 18/5. Make sure you write the ordered pairs for the answers. I would expect the one on the test that has this structure to have 2 answers also. And the fact that this came out to a nice rational solution, I would expect the one on the test to do the same thing also. So just be careful that you square this binomial properly. If you're not sure about the shortcut on that, you just FOIL it, 2x minus 4 times 2x minus 4. F, 4x squared. O, negative 8x. I, negative 8x makes negative 16x. Negative 4 makes 16. So you can always FOIL it if you can't remember the shortcut. But just be careful that you expect to get rational solutions. You should get rational solutions. And again, don't abandon your variable. When it says x squared, make sure you write x equals. If you put just this number, and let's say it's y's in this case, you found y's, you're going to mess up getting the rest of it. So make sure you don't abandon variables in your work. Number 10, system of 3 equations with 3 variables, x and y, x and z, x and z. Now, these 2 equations only have x and z in it, so I can immediately use that system right there. So just ignore the top equation as it's written. So 3x minus 3z equals negative 3. Negative 3x plus z equals negative 9. And I can immediately just go ahead and start working it out. So 3x minus 3x cancels. Negative 3z plus z is negative 2z. Negative 3 and negative 9 is negative 12. So z is equal to 6. Once I know z is equal to 6, I can go back to one of these 2 equations here that have x and z in it. I'm going to go right here. So 3x minus 3 times 6 equals negative 3, which means plus 18. 3x must equal 15. So x must equal 5. Wants to know x and z. I can go right here to find y. 4 times x, that's 20, because x equals 5. 4 times 5 is 20. Plus 2y equals 24. Move the 20 over here. 2y is equal to 4, so y must equal 2. And once we get all three variables, x, y, and z, again in order triple, x first, y second, z last. Ordered triple gets you full credit, x equals y equals z equals get you half credit. Give me ordered triples, ordered pairs on systems of equations. Number 11, graphing a system of linear inequalities. I'm going to try one new technique here that might help you with the shading part, because I think that's what most people are stressing over right now. First thing I want to do is establish a graph for each of these. So let me start with this. I'll make it in blue. Negative x minus 2y equals negative 8. I'm going to move the 2y to the right, the 8 to the left. So I'm going to get negative x plus 8 equals 2y. Divide everything by 2, I'm going to get negative 1/2 x plus 4 equals y. So notice equals, because I'm just graphing, it's a line equation. So that's the linear equation. 1, 2, 3, 4 is the y-intercept, and the slope of negative 1/2 takes me down 1, right 2, down 1, right 2, and so on. So it gets me this line, which is going to be a solid line because it says equals 2. So get some blue line. So there's my line there, solid as it should be. Then my second equation I'm going to do in red. I'm going to call it y equals 3x. And that's already in slope-intercept form. So it's got a y-intercept of 0, slope of positive 3, which is up 3, right 1, or down 3, left 1. So if I connect those with that line, I'm going to make it red. This line is going to be a dashed line because it's just less than, it's not equal to. So it's going to look like this. Oops, that shouldn't, there we go. So here's the difference I want to do here. Maybe this will help you. That creates 4 regions. I'm going to name those regions. We'll call this one up here, and this nook over here, call that A. This one over here we'll call B. This one over here we'll call C, and this one down here we'll call D. Those are my 4 regions. And I want to pick a test point that does not lie on either line. So I'm going to pick 1, 1. Okay, 0, 0 is not available this time. The red line goes through it. So 1, 1 is a perfectly fine test point. And what I want to do with that test point is I want to go back to the original inequalities as they're written. And I want to change x and y into that number. So my test point is 1, 1. That's x equals 1, y equals 1. If I go into the blue equation, or inequality, and put 1, 1 in place of the x and y, I'm going to get negative 1 minus 2 times 1 is greater than or equal to negative 8. Negative 1 minus 2 is negative 3. Now I got to look at that statement to see if it's true or false. I can see that negative 3 is bigger than negative 8. Imagine your number line, negative 8's left of negative 3, so negative 3 is bigger. This is true. Okay, so if I look at the blue line, here's the blue line, here's my point right here, which is true. So in relation to the blue line, regions C and D are both going to be shaded for the blue dot, because the blue dot's where the truth is in relation to the blue line. If I take the same test point, or a different one, it doesn't matter, I'm going to take the same one though. There's my test point for the red inequality. I'm still testing 1, 1. That's x, that's y. If I put 1 there, I'm going to get 1 is less than 3 times 1. That's 1 is less than 3, which obviously is true. So look at the point in relation to the line. Here's the line, here's the point on this side of the line. What's on the same side of the line as the point are B and D. So C and D are true for the blue line, B and D are true for the red line. The only one that's true for both of them is D, so that's what you're going to shape, region D. If that helps you understand it better, by all means do it that way. That's the same way I've been doing it every time, I just didn't name the regions yet, but that works if it works for you. So if you can just identify what's true, this point is true for the blue line, the 2 regions in the same relationship are these 2. True for the red line, these 2. This is the only one for both, so that's the one you're going to shade in. Number 12. And anytime I see radicals in a problem that says simplify, my first priority is looking at the radicals themselves. Can I make them any simpler? Square root of 3 is as simple as it can get. So I can't make that any simpler by like pulling out a perfect square factor. So now I need to multiply by 2 minus the square root of 3 on both top and bottom. On top is just a FOIL. So if I'm looking at the top, it's going to be 3 plus 5 times the square root of 3 times 2 minus the square root of 3. First times first is 6. Outside times outside is negative 3 square root of 3. Inside times inside positive 10 square root of 3. Last times last is going to be positive times negative makes a negative. 5 times 3 makes 15. This times this makes 3 times the 5 makes the 15. So altogether the top, most simplified version of the top is going to be negative 9 plus 7 times the square root of 3. That's my top. As far as the bottom is concerned, the bottom is just a difference of square structure. So 2 plus the square root of 3 times 2 minus the square root of 3. All I have to do is first times first is 4, last times last is minus 3, that equals 1. So that's the bottom, 1. So the answer is simply the top over the bottom, so it's negative 9 plus 7 square root of 3 over 1. Over 1 doesn't do anything, so I can sleep like that. If it came out anything but 1, just be over that number. So like, let's say it said 4 minus 1, this would be 3, so it would be that whole thing over 3. So that's how you do those. Again, the fact that these were already simplified as much as possible to begin with, I'd expect one on the test to be similarly structured. Number 13, 75 feet per second to miles per hour. So 75 feet per second. So again, putting things where they belong on these problems. Feet per second, feet on top, seconds on bottom. I want to convert feet to miles. So currently I got a unit of feet in the numerator, and the conversion factor is that 5,280 feet is equivalent to 1 mile. Foot on top, foot on bottom. Feet cancel, miles are left. Now it's miles per second. I want to convert from seconds to hours. Currently seconds resides in the denominator. I know that 1 minute equals 60 seconds. That gets me from seconds into minutes. I know that 1 hour is equal to 60 minutes. Minutes on bottom, minutes on top cancel. I'm into hours. Now it's miles per hour, so what's left to do is just get the numerical answer. It's 75 times 60 divided by 5280. Comes out to 51.14 miles per hour. Round to a couple decimal places if it doesn't come out nice and pretty. Number 14, find the distance between 3, negative 1 and 6, 5. So x6, x3, it is exactly 3 spaces from 3 to 6. We want to square that. Negative 1, 5 are the y's. It's exactly 6 spaces from negative 1 to 5. We want to square that. How far apart are the x's? How far apart are the y's? 3 to 6 is 3 spaces. Negative 1 all the way to 5 is 6 spaces. Square both things. Notice I wrote positive numbers for both of those because you always are going to square. You're always going to get a positive result anyway, so don't ever write negatives in this problem. 3 squared is 9. 6 squared is 36. The square root of 45 is the right answer. I would prefer that to be written as 3 times the square root of 5. Because we know the square root of 45. 45 is 3 times 5. Pair of 3's gets to pull out. That's the exact answer. I'd be fine with an approximation also. Square root of 45 equals. And it comes out to 6.71. So either give me the simplified radical expression or give me the decimal approximate answer. Either one would be fine with me. I'm not going to count the square root of 45 wrong, but if you're going to go that route, give me the exact answer. Number 15, find h plus p of negative 4. So the only way we can evaluate this whole thing is if we can evaluate each one of these functions for this argument. 4 is a real number, it's also a negative integer, so it's legal to evaluate both. I want to figure out what h of negative 4 is. H of negative 4 is x squared. So x is changed from negative 4, and negative 4 squared is positive 16. P of x is x cubed, so p of negative 4 means negative 4 times itself 3 times, which is negative 64. Negative times negative makes positive, times a third negative makes it back to negative. 4, 4, 4 makes 64. H plus P means we're supposed to add these two results together. 16 plus negative 64 is negative 48. That's my result. If this said positive integers, I couldn't do it, I'd put an empty set. If this was H plus P of 1/2, 1/2 is not a negative integer, I couldn't do it. If it said H plus P of 17, it's not a negative integer, I can't do it. So again, that's the only thing that might throw a wrench in this problem is you might have to empty set it because this number does not match one or both of these sets. But if it does match both sets, evaluate both individual functions, then perform that operation to them.